As part of certifying our propellers for CSP in Europe and Park 35 in the United States, we are working to demonstrate our propeller's ability to survive a bird strike. To be able to carry out these bird strike tests at eProps, we decided to build our own chicken cannon so we could recreate the impact between a block of gelatin representing a bird and a propeller. We chose to equip ourselves with our own cannon to be independent for the tests so we could run them on our own schedule and not depend on the labs that offer this kind of service. First, because very few labs in Europe do these tests for propellers, so availability isn't always guaranteed. And second, the bird strike criteria are the same for a small general aviation propeller as for a large aircraft propeller. It's the same bird weight. The challenge is much greater for a small propeller, so we wanted to be able to do many shots to adjust the parameters and optimize the propeller for bird strike resistance. The cannon is behind me. It's mainly a 9-meter long tube that can launch typically for a propeller test, a 1.8 kilograms block of gelatin at about 800 to 900 kilometers per h, depending on the impact point on the blade. The cannon can actually do more. It can normally launch a 3.6 kilograms chicken at Mach 2. The certification standards for these tests are for the American Part 35, Chapter 36, and for the European CSP, Paragraph 360. And what provides a bit more detailed framework for the test is the STMF 300-3021. To check that the tests are representative of the standard specifications, the cannon is equipped with 2 barriers to measure the projectile speed and a camera filming at 8,000 frames per second to verify the point of impact of the gelatin block on the blade. For this shot, we set up a Ascalon propeller, and the pitch and speed were chosen to represent a full throttle initial climb condition. One of the moments when bird strikes are most frequent since they mainly occur at low altitude during takeoff or landing. And for the propeller, obviously takeoff cases are more violent since the propeller is spinning at high speed. The sequence, a bit of a shot. At the end of the test, we see that the blade is intact. The propeller perfectly withstood the impact with the 1.8 kilograms gelatin block. The test is a success.